Okay, James. Well, I'll get things underway by introducing me. I'm Peter, and I'd like to welcome everybody to our presentation this morning. But this is one in a series where we try to educate our customers on the products that we're using. And conducting this series of presentations is James Newell. And James, I'll hand it over to you to let us know about today's topic, which is basic calibration of balances. Welcome, James.
Thanks, Peter. As Peter just mentioned, today's topic will be basic calibration of balances. But before we get started on that, I'll give you a quick rundown on the types of balances that most of our customers will be buying, and just a little bit of servicing before we actually start with the calibration. So generally, we call these balances. A lot of you would actually call them scales, and I'll be honest, it makes me cringe every time. But that's okay. That's okay. So we would consider anything that's below a kilogram to be a balance, and anything that's got a higher precision than 1 decimal point is a balance. Anything above that, they're scales, whatever. We don't really care so much. No, I'm kidding. We calibrate those too. But for today's presentation, I'm mainly showing you balances because scales are very big and heavy, and well, I don't want you to see me trying to lift 20 kilo masses onto those things. It's very embarrassing. Anyway, so one of the most common balances that a lot of our customers would be purchasing would be something like this. It would be an open top pan balance. This is something that we actually sell to schools, as this is actually quite robust. It goes down to 2 decimal places. It is dust and water resistant, which is fantastic because kids will somehow get all their specimen within the mechanism somehow, and it's also quite robust. This particular model can usually take a beating because, well, sorry about the noise, because when children weigh things, they just chuck things on. It's got a 400 gram limit, but it can take the shock of more than that. If you want to know more, feel free to inquire about the A&D EJ410. That's what this particular model is. Okay, so that's a basic balance. You'll find them in schools and actually a lot of pharmacies, but the pharmacies will tend to use high precision ones. All right, let's put this away. All right, next up would be something that's less commonly used. This is quite an advanced analytical balance. The reason this is really advanced is because this particular model goes down to 5 decimal places. Now, if you're going to be using a balance like this, of course, you're going to need to make sure that the environment around it is suitable. So what I mean by that is you want to minimize airflow, and that's why there's this huge enclosure around it. And even then, you want to make sure there's no ducted air conditioning blowing directly on it. You'll want to have the air as still as possible. If you can, put it into a small room, close the door, make sure there's just as little airflow as possible. And also make sure that the temperature is actually around room temperature and it's stable. That will also help. The bench will need to be very sturdy. Something like a granite top on a steel frame is really good. And as well as that, you'll want it to be on a concrete slab or a concrete floor, preferably on the ground floor, because the higher up you are in the building, the more it actually sways, and there's various vibrations and things like that that will affect it. These things are so sensitive that on this particular bench, someone walking in the other room will actually affect this right now. And that's on top of the air conditioning and all that kind of stuff. Right behind me, we have an air-conditioned room that we actually use these in, and that's where we conduct our tests because it's a lot more stable. These things tend to have quite a few features in them, such as internal calibration masses and quite a robust, accurate system within. These also have automatic doors, so that it limits the amount of contact that you have with the instrument itself. The reason you want to do that is because you want to limit the amount of vibration that you apply to the balance. This thing is great, even though it's quite old. This thing's great because you can press a button and it will actually slide open like a teleporter. I've always told everyone this kind of looks like something from Star Trek, and when they see the door actuating, it just further emphasizes that. You can gain access from the top, sides, and as I said, this door slides open from the front. A lot of advanced analytical balances also have a removable display / control, and it usually has a cable running into the instrument. And the purpose of that is so that you can actually put the balance somewhere very, very stable while having the control unit further away, so that when you're tapping away at it, it doesn't actually affect what you're weighing, because when you're weighing things down to 1 milligram, literally a small breeze will affect it. Okay, put this away very gently. All right, one thing you need to be mindful of with these kinds of balances is that you shouldn't be moving them. Now, of course, especially in university settings, you're going to need to, because the labs won't necessarily be set up and ready for students to just be able to weigh their specimens and conduct other experiments in the same space. And you've got to cram in as many kids into the room as possible as well. So when you're moving these, of course, you're going to want to be as gentle as possible with these. And you will also want to make sure that you prepare your instrument accordingly. So your balance will normally look like this when it's in use. Hands in, there's nothing around it. But if you need to transport it, I would highly recommend not doing so. But if you have to, I would highly recommend taking the top pan. What you want to do is gently remove it and actually turn it upside down. Balances tend to have a ring around the contact point to the load cell, and that will actually help protect the load cell itself in case there's an accident. So that's a form of overload protection, but it's not perfect. Obviously, if it receives a sharp shock, it can destroy the load cell, and it can destroy all the mechanisms inside. Now, putting the pan upside down will help with that. It'll help stop things from contacting while it's being moved. And just place the ring back on there to retain it, stop it from moving around so much. And then this will actually enable you to take your cable placed on top. So for a university setting, this is perfect. This is perfectly fine, because you tend to take it from the location of use, put it onto a trolley, and you take that trolley away for storage. That'll be okay. If you have to ever transport it off site or between sites, which a few of our customers will have to do, I recommend that you pad it with something, some styrofoam, some bubble wrap, put it inside, make sure that there's just very little movement. There's no way for the pan to get jolted off and just get displaced, I guess. Flip over and have the load cell contact point exposed. So yeah, you don't want that in transports. So you want to make sure everything in here is as still as possible. Or if you're still unsure, just remove everything and keep it all separate. Close all the doors, tape it shut if you have to. Obviously, make sure you don't use anything with ridiculously high strength adhesive, because it will be a nightmare to remove. Just one more thing on transport. If you are putting into a vehicle, I would not recommend placing it in the boot, and I definitely would not recommend placing this in the back of the ute, because of the way that the suspension is set up. Leaf springs aren't for comfort. they're for handling heavy loads. And so what tends to happen is they can be very bouncy, even if you're trying to drive carefully, and this thing can move. What you should instead do is place it in the second row of seats, in the passenger seats, place it on the floor. And what you'll want to do is actually move the front passenger seat back so that this is actually held in place by the two seats. Make sure it's nice and stable, nice and snug, and that'll help avoid any potential damage. Another thing to note is that if your balance is NATA accredited or has been NATA certified, the second you move it from this location, the location of its test or certification, it becomes null and void, because that's where it was tested and that's where it was certified. So even this has actually effectively nullified the certification. So if you need to have your balances NATA accredited, please make sure they stay in the location that they need to be in and to test. Okay, so let's move on to the actual calibration of the units. We've already taken up 10 minutes of your time. First thing you want to do with these is actually plug them in. Make sure it's plugged in, give it 15 minutes to warm up. Otherwise, you might not get the, well, you just need it to warm up so that it can perform correctly. And what you want to do after that is make sure it's clean, because if it's a dirty balance, obviously lots of things can go wrong, and you want to do a quick inspection before you actually start calibrating, because you don't want to calibrate to an error. You want to make sure you eliminate all of them. First thing you want to do is make sure you dust it all off. So just use a brush. That's perfectly fine. I'd also recommend using a blower, but obviously brush it off first. Otherwise, if you're using a lot of powdered samples, it'll just go everywhere. And in particular sites, it can be hazardous. You don't want to be breathing that in. All right. Next, what you want to do, so once you've done the exterior, next, what you want to do is remove the pan very gently. Make sure it's clean, because any residual chemicals can actually transfer over and contaminate your masses, and you don't want that, because over time it can corrode and gain weight through that way. You'll want to inspect the contact points of the top pan. I don't recommend touching it if you have a high precision low maximum weight mass. I recommend just blowing out any debris that's in there, and that's all you need to do. When you clean them, you can use a cleaning solution, such as the one I use for the microscope servicing process. So 50% ethanol with 50% window cleaner. Spray that onto a cloth, don't spray it onto the instrument. You want to wipe the inside, make sure there's no debris, make sure you don't touch the load cell. It's also worthwhile cleaning the rails to make sure that your doors don't stick. Do the other side. Sometimes a cloth isn't enough to get in there, so you'll want to use a cotton bud or Q-tip. That'll also be very helpful. Make sure those rails are clean. Another thing on cleaning the exterior. While the windows might be glass, the display screen might not be. These are often made from polycarbonate, and as a lot of you will know, you shouldn't get solvents such as acetone onto it. But if you have a 50% mix of ethanol in whatever solution, or even isopropanol, that should be fine. It shouldn't interact with the plastic itself, and it shouldn't cause this to fog or whiten. All right. You want to inspect your pan again, make sure the contact point is clean. Sorry about the noise, because any grit inside here, in between here and the the contact point of the load cell will affect your results. It can actually cause your pan to skew slightly, and it might give you some false results. When you place it on, it's worthwhile quickly doing the rotating it a couple of times and just pressing down very gently, just very slightly, to make sure it's seated correctly. Okay. Now with these analytical balances, they'll often have an internal calibration mass inside them already. To activate it, they tend to have a mechanism, especially in the older models, they'll have a mechanism that's accessible from the outside. So for this old Metler, it's just a slide mechanism, which is nice and easy. This A&D has a small lever. Now, of course, over time, these can deteriorate because they're not actually enclosed within an airtight enclosure. And so over time, it can oxidize, or if there are chemical spills underneath, it can interact with that as well. So over time, you're going to need to get that rechecked. But for standard use, the internal calibration should be just fine. Now to calibrate, it's generally very easy. They do it all by themselves. With these ones, they do it all by themselves. And some of the more advanced or higher end open top pans can do it as well, like the FX 2000s and even the 200s. They'll have an internal mass. No, sorry, FZ. FZ is the designation for that. They'll have their own internal mass, and it makes it easy, especially if you are using it constantly. And often, to activate that, all you have to do is just press cal, and you just allow it to calibrate by itself. Now, when you do that, you want to make sure you are having no contact with the balance itself. Again, that means done. Good. With some instruments, you'll actually hear a motor activating and running. With these ones, it's all manual. So I think I'm just about to put an error into it. Okay. Anyway, not all models have an internal calibration mass, and so a lot of you will actually have some certified masses with it. Now, this is my calibration case. It's got masses in it ranging from 1 milligram all the way to 5 kilograms. Let's close that up. One thing you'll have to you should note is that when handling these masses, no matter what the coating is on the outside of the mass, no matter if it's a stainless steel or if it's chrome polished, you should never ever handle it with your bare hands, because the acids in your skin oils will actually interact with the material and over time oxidize it, causing it to gain weight. Make sure when you wear a glove that this hand is only used for contact with the masses as well, because interaction with anything else can potentially contaminate them. That's another thing to be mindful of. We use, I think this is cotton. We just use cotton gloves. I'd avoid things like nitrile. It should be okay, but the problem is when they're processed, there's going to be some residue on it, and that can transfer over onto these. Just wearing plain cotton. Polyester should be fine as well. Is better. Now, when you're doing an external calibration, it's pretty much the same process, except, of course, you're going to be introducing an external mass to it. These will always give you an indication of what to do. So generally, when you enter calibration mode, it's going to want to zero first, and then after that, it's going to ask you to place the mass on, and then, as an example, place the mass on. Just do this gently. Close the door, and it will give itself some time to balance out for the mass to be calibrate inside to make sure the vibrations have stopped before it actually takes the reading, and uses that to recalculate what the baseline is. And then after it's done, it'll ask you to remove the mass. It'll re-zero just to double check, and it'll do it in its own time. And that thing is going to take a while because this is a very unstable bench. These kits also come with forceps, so if you prefer, you can use these. They're generally for the smallest masses, so this one is a 1 gram. There to help you handle these. You can also get larger ones to handle larger masses, but gloves will be okay. Something else that you need to be mindful of is the linearity of the performance. So with anything, really, anything that's manufactured, there's always a tolerance, and there's also a certain level of performance that they can, a certain level of precision that they can perform to. And if you were to plot it out on a graph, it would look something like this. Let me just get from the camera. All right, so it would look something like this, where the black line here is the optimal performance. So that represents a perfectly performing balance, where the actual mass and the reading of the mass of the not scales, the balances, perfectly correlate with each other. But often that is not the case. These dashes actually are representative of the tolerances of the machine itself. Now this balance here measures down to can actually measure down to 0.2 milligrams. No, 2 milligrams. Sorry. But it's and that's its tolerance. So it's yeah, it's the actual mass, give or take 2 milligrams, and that's its actual accuracy, and that's what these dashes represent. Now this red line here represents the actual performance, and the reason for linearity is the reason why we have to calibrate for linearity as well is because we want to correct this red line as much as possible, because no balance is going to work exactly perfectly on the lower end as it does with the higher end. And also along its span, sorry, this is really difficult when it's mirrored, and along its span, it's going to be slightly variable as well. So the reason for a linearity test is to actually test at different given points along the along its span, and try and correct for those. Now, when you're doing a standard mass calibration, all you're doing is, oh gosh, taking this red line and just adjusting it up and down. You're just trying to correct for whatever given set point it is. So for instance, the mass behind the balance behind me has a maximum of 120, which is, let's say it's up here, but we calibrate to 100 grams. So it will actually move this line up to the correct amount, but the problem is it'll actually throw out the rest of it. All it's doing is moving this line up and down, and our linearity test will correct this line itself. I wouldn't recommend doing the linearity test yourself unless there's something that you've been trained to do, because if you make a mistake, it could be somewhat catastrophic, and it could be as bad as actually causing the entire unit to essentially, to use a phone, technical phone terminology, to become bricked, where it gets to a certain setting and you can't get it back to a proper working order. At that point, you'll actually have to go back to the manufacturer or a service technician and have them reset the entire machine. And sometimes that can actually involve plugging this into a computer and then just totally reprogramming the whole thing, taking the program, wiping it, resetting it, and then reinitializing, which you don't want to do. That's essentially all for the presentation. If you have any questions, please let me know. Feel free to either type it in or just speak to me.
Yes, I'm sure people might have questions about that linearity test, James. So how often are they conducted on balances?
We check them every year. Well, when I go and service instruments, I check them myself because, of course, we want to make sure they're as close to the tolerances as possible. Going back to this, it shouldn't fall outside of these tolerances, the dashed lines here. And if it does, that's actually a whole nother issue that we need to sort out. But yearly we do this. It's more of a check than anything. We don't necessarily have to do it, but yearly.
No worries. So just the last opportunity for any questions to come forward, either audibly or pop them in the chat. Here we are. Anne's got one for you there.
How can I correct an Outhouse Scout SKX balance that is showing an error, 8.1 error? I have no idea, I'll be honest. If you would like, actually, I'll be honest. If I'm working on a German balance like the Outhouse, I tend to just Google it. I download their manual, read through it, see what the error is first, because it could be something as simple as not getting the correct amount of power into it. It might not be balancing. We don't know what the error means. So first of all, just type in Outhouse Scout SKX, error 8.1. And from there, you can diagnose what the issue is. But if you're having troubles with that, feel free to just email me. So just email me on, actually, let me type it in here. If you're having any issues with that and you can't rectify it yourself, you can just email me at service@aispl.com.au, and we can take it from there. If that is helpful.
That's good advice. Thank you very much, James.
Yeah. Sorry, I can't think of it off the top of my head because it's not something that I often come across, and we are A&D techs. We can work on other balances. It's just that we're not as familiar with the other brands. That's all.
Well, it's not so much knowing the answer to every question, it's knowing that you can find out the answer if you need to.
That's exactly it.
Yeah.
And that's actually why we have all of these manuals here. They go into every minutia of detail when it comes to all these instruments.
Excellent. Oh, have you got? Oh, that was Anne. Okay. Well, we'll wrap it up there, James. Thanks to you and thanks to everybody for your attendance today. And we'll be back next month with another presentation. In the meantime, please stay safe and we'll look forward to seeing you then. Thanks very much, James.
Just quickly, John, yes, of course, you can purchase the calibration weights from us. Just send me an email through that service link and we'll take it from there. I'll pass you over to our national sales manager and he can help you out.
Beautiful. Thanks so much, James. Thanks, everybody.
Thank you.